Today we are going to discuss about volumes. So before understanding the volume concept, let me explain you what is the stateless and the stateful applications. So I'm going to explain you there are the two types of applications known as stateful and the stateless. What are stateful applications? Stateful and stateless applications. So what are the stateful and stateless applications? Let me explain you. So let's say this is a Docker server where I install the Docker, right? And you have a container which is known as a Tomcat container. This is a Tomcat container. What is Tomcat container? It is a web container. It is an interface container. And one, you have a DB container. This is a DB container. So in the DB container, the DBAs will be storing some data files. So here you are having a DB files. So at the name states, stateful. When you're saying stateful applications, it is an where my database is stored, like my Jenkins server where the data is stored, the database server where data is stored, or my MQ server where MQ's queues are stored. These are the stateful servers. Whereas a Tomcat is a web interface, is a stateless because it does not store the data. It is only an interface through which my application will be connected to the database. So my application will be connected to the database. So this is my Tomcat container. So this is my stateless application. This is a stateful application. So in this project, we are going to use a couple of things. So one application I'm having, this is my GitHub location. And then this application, what I'm going to use a source code which has been developed by the developer to connect to the database. This is they are using a Spring Boot application. This is a application it is having the inbuilt Tomcat enabled. So you deploy the jar file, automatically the Tomcat is there inside that, and to the web application you can connect to the database. So he has written some code here. He has written some code here to connect to the database. So this is my application YAML file. So in this he has written to connect to the MongoDB. MongoDB is a document collection database. Basically it's a documented database where we can store the information. More importantly, so he has passed some variables. So MongoDB hostname, MongoDB username, and the password. This is the username password you are going to use while creating a MongoDB container. You can pass a username password. The same username password you have to use. So how do you know? Let's say hub.docker.com, and I will show you Mongo DB containers, where you can get these informations. If you access it, so let's say Mongo DB. So this is my Mongo. So my Mongo container is this is my database. If you go down, it will tell you how to create a MongoDB container. So here you have to create a network. The network you need to create because your Tomcat container and the database container will be connected with the name. If you need to connect with the name, you have to create your custom network. So we will be creating a custom network. If you're not creating a network, but as we all aware that it will be creating in a bridge network, and then the bridge network we can only connect through the IPs, and IPs are not reliable in the container world because it's keep changing in the DHCP IP addresses. So this is the way we can create the MongoDB container, where we have to use the username and the password. The same username password we will be passing while we using the Spring Boot application, while we're creating the Spring Boot application container. The same username password we will be putting in. So this is the way we create a container for the MongoDB. So let's go into the server, and that will help us to explain better. So this is my container database. I have created a server where I have installed Docker. So here is my key stored. So I connected with my server. So first see network. So I do have the default network. I have created a Flipkart bridge. Let me delete all the networks. So it has been deleted. If you see ls, by default bridge, host and none, 3 type of networks is there. So no custom network is there. So let's first create a network. So here is a way I have written it step by step. You can create Docker network, create, give any name. I have given this Flipkart bridge. So you have to see -d is a driver, bridge driver. So these 3 drivers are there: bridge, host and none. So you can create a Flipkart bridge. So you can see a bridge network has been created. Now I need to create a container. I have to create a container of my DB. So in this case, I'm not going to use a volume. Let's remove this volume for better understanding. Okay, I have to create a only MongoDB container. So I am giving my db run -d, name mongo1, -e environment variable, the way it has been written into the hub.docker.com username, and I am giving one password. I am using a network Flipkart bridge which I have created in my first step, and I am passing the image name Mongo. If I am not giving any tag, it means it is the latest. Okay, so let me create. So it is saying image is not there locally, so it is pulling the image and downloading the image and creating it. So what I'm doing here, my MongoDB container is getting built. Okay, so you can see Docker PS, my MongoDB container is built. So let's see Docker inspect. Before creating my web application container, I'm going to show you. So it is using a Flipkart bridge network. If you are using a custom bridge, you can connect with the host name. Okay, now I have to create a container, Tomcat container. Like here I am using a Spring Boot. For this I have an image in my hub.docker.com. If you go here, this is my hub.docker.com. 2 days before I have created an image Spring Boot here. If you can see here, this Spring Boot image I have updated 2 days before. So I'm going to use this image to create my container. So for that I have written here, I will explain you before running this. So I am saying docker run, that is creating a container and creating and running the container. Minus D is a detach, name is a Spring app I am giving. I am doing the port mapping. So this is my host port and this is my container port. I'm giving the environment variables Mongo1, which I have given here, name Mongo1, username, password, network, and I am giving my image name. Where is my image? You can ask one question: why you are creating a Mongo database? You are not giving the port mapping, because this is internal to the container. See how it has been connected. So it is a very good concept. So let's say my user has been here. My user is going to connect with the Tomcat application. I will just making opposite to that arrow. So it is going to go to the Docker, and here it is going to connect with this Docker. This is a port 8080. This is the 8080 which I am talking about, host, and it is going to connect with my Tomcat container port, which is known as a 8080. So 8080 minus P, this is my, so it is going to connect with the host name and the port. Host name, port is of the host, and there it is going to connect with my Tomcat port application, that is a container port, that is 8080. So this is a mapping I need to do. So once a user is going to connect with the host name, and then it is going to internally connect to the Tomcat. Tomcat will connect with the DB host. So it does not require the port mapping. It does not require the port mapping because it's internal to the container. So you understood the concept. Let me create this image. So it is creating an image. So once this image has been created, if you say docker ps, this is also created into the network bridge of Flipkart bridge. So both the containers are on the same network, so they can talk to each other without any problem with the host name. So let's see my IP address, this, and I will be connecting with the port. You can see my application is up. My Spring Boot application is connected to the MongoDB. So let me add some data. Nitin, and I'm putting some data. So my data is going to stored here. So where this data, let me add one more data. So where this data is going to be stored, this data is going to store in my MongoDB container internally. So if we say docker inspect Mongo1 and you go a little bit up, it will be showing you the volume where it is going to have that. So this is the volume, this is a mon point. Internally it is managing and it is having all the information of your data. So where this all data will be stored, you can find it out if you go docker execute minus interactive, and I am going to say Mongo1. So this is my database name, and I'm saying bash or /bin bash. So that is the way you have an interactive mode. So say go to the data, go to the DB, So all information relating to your data will be stored in this location, Now what I will do, I will be dropping this rm minus f mongo 1. So I have dropped this container. You can see my only Spring App application is there. Now if I will refresh, you can see this data. Let's see. So my container has gone, my data is also gone. Now how can I store the data? How can I store the data inside the Docker? I don't want to store the data in my here. I want to store my data to be stored. My data should be stored. Sorry for that. So my data should be stored here. How I need to make it ensure that my data should be stored into the container here. So let me make it. So my data should be pointing to this location. Okay. So it should point to my location here. So my DB files should be stored locally into the Docker container. How can I make sure? So there is a concept known as a volume. So the volume concept says, so what is a volume concept? The first line I stored, it's volume are stored in the part of the host file system which is managed by Docker. So there are the two types of the management, which is known as the bind mount, and there is a Docker persistent volume. What is a bind mount? Any folder or the file which is on the Docker, which is on the server, you can create it and mount it and map it to the configuration files of the database. So let me explain you with an example. So here I am going to create a directory. Let's say MongoDB container. Okay, I'm going to MongoDB container and seeing this location. So this location. What I will be doing, instead of creating my volume here, I have to give us -v, that is a volume. I am saying local volume which is on the Docker server point to this container location. So the first location, just like the port mapping, we are giving the first is to the host, and then we are saying container port. The similar way here we are giving a container volume and this is a Docker volume, that is server volume, and my container volume. So volume is nothing, it is in storage. Volume is nothing, it is in storage. Don't consider as a backup, it is in storage. Let me create the container once again. So Docker ps, my container is up. If I inspect Mongo 1, go a little bit up. So here you can see the mount. It is a bind mount. This is the source location, and this is my location of the container. You can see the bind mount. Okay. So let me here, if I say ls minus lrt, you can see all the files copied automatically. You observe that we have not copied the files. As soon as I create the container, all the important files will be created in this location. Will be created in this location. If we go to the application, let's say submit the data. What is the drawback in this? What is the drawback in this? Now, if I will drop my container, still I have the data locally. So I can build my application, bring my container again with the same mount point. Let me show you. So I'm saying docker rm-f mongo 1. You can see I have dropped my, if I refresh it, you cannot see the data, but I can retrieve the data again, creating the same container with the same location. And if I will say here, you can see my data is back. So this is the bind concept of the volume. What is the drawback in this volume? The drawback in this volume that this is reachable to the human user. I can change, I can remove any file in this location. Let's say I want to add, say, touch backup file. So I can create a backup file. I can delete any file which is not recommended in the productionized systems. And these different folders, how many times you can, or how can you manage these mount points? You need an automated management. Okay, so that concept is known as a persistent volume. The persistent volume, this is a volume which is managed by the Docker. For that, you have to create a volume. So if you can see here, Docker volume ls, these are the volumes available. Let me Docker volume prune and Docker volume. So you can see no containers. This is the external container. There's another concept, but you can see no containers, no volumes is there. So let me create a volume. So the command of this docker volume create -d. D is the driver, local MongoDB. I'm then giving the name. So just create docker volume create -d local. I'm giving a local container. I'm saying MongoDB. So MongoDB container is created here with the local driver. So they are the external drivers of the local drivers. This is an external driver. I will explain you probably in the next recording. So in this, the MongoDB has been created. So who will store this information? If you see docker inspect Mongo. So this is being managed. This is being managed by the Docker itself. This is managed by the Docker volume itself. So there are the different type of networks and overlays. I will explain you. So Docker volume ls. So this is the volume I have to use while creating the container. So let me create the container that will help you explain better. So instead of creating my local directory, I am giving this location. So docker ps. So my Mongo is there. Let me rm -f mongo 1. It has been deleted. Let me create this container again. If you inspect Mongo 1. So previously it was bind. Let's see what is that this time. This time it is created with the type volume and the name has been changed, MongoDB. And the source, we have not given this location. It is automatically be picked. Let's see, as a normal user, we can access this application, this mount point or not. So let me go in this location. See, you can see permission is denied. So we cannot access this application, and it is stored and it has been used, I would say, it is being managed by the Docker itself. So this is the concept of volume having a bind and the persistent, Docker persistent. Docker persistent is a persistent volume. It is not, it is managed by the Docker, and the normal user cannot access this location. If you want to access this application, you need a root privilege. So this is the all explanation of the bind volume and the Docker persistent volume. And if you inspect, so I want to show you for the sudo privilege. If you go into sudo privilege, as this we do have the privilege, we can go in this location. I can see all the files be copied here. So my volume will be stored here. So this is the positive part, having a volume concept. It is not dependent on the containers. It is dependent on the Docker server. It is dependent on the Docker server. I don't want to depend on the Docker server. There is a concept of the Docker external volume that we will discuss probably in the next session. Thanks for joining.